so we will be explaining about the types of digital to analog modulation, which is content of ASK, FSK, PSK, and finally QAM. Let's get started.
I'm going to talk about amplitude shift keying. Amplitude shift keying is a form of modulation that represents digital data as variations in the amplitudes of a carrier wave. The amplitudes of an analog carrier signal varies in accordance with the bit strings, keeping frequencies and phase constants. The level of amplitudes can be used to represent binary logics, zeros and ones. The bandwidth for amplitude shift keying is 1 plus d times s. Binary amplitude shift keying or on-off keying. Amplitude shift keying is normally implemented using only two levels. This refers to as binary amplitude shift keying. Think of a carrier signal as on and off switch. In modulated signal, logic 0 is represented by the absence of a carrier, thus giving off or on keying operations, and hence the name given OKK. Multiple shift keying. We can have multi-level amplitude shift keying, which there are more than two levels. Use different amplitudes for the signals and modulate the data using more bits at a time. Demodulator. Demodulator determines the amplitudes of the received signals and make it back to the symbol it represents, thus recovering the original data. Advantages and disadvantages of amplitude shift keying. Advantages. Amplitude shift keying, transmitter and receiver are simple to design. Amplitude shift keying needs less bandwidth than frequency shift keying. Disadvantage. Amplitude shift keying transmissions can be easily corrupted by noise. Amplitude shift keying needs high power consumptions. Amplitude shift keying not suitable for wireless communications. The amplitude shift keying is used in satellite link, early telephone modem. Amplitude shift keying is used to transmit digital data optical fibers.
Frequency shift keying is frequency modulation scheme in which digital information is transmitted through discrete frequency changes of a carrier signal. In frequency shift keying, the frequency of the carrier signal is varied to represent data. The frequency of the modulated signal is constant for the duration of one signal element. Changes for the next signal element if the data element changes. Both peak amplitude and phase remain constant for all signal elements. Frequency shift keying also represents two types of frequency. One frequency is correspondent to a high value of hertz and another represents zero value of hertz. The most basic frequency shift keying is binary frequency shift keying. BFFSK involves the process of varying the frequency of a carrier wave by choosing one of the two frequencies in correspondence to a sequence of digital pulses that constitute the information signal. Two binary digits are represented by two frequencies around the carrier frequency whereas the amplitude remains fixed. This is how binary shift keying looks like. This form, the red form represents data signal, the black form represents carrier signal, the blue form represents modulated signal. The red form is input binary sequence that have to pass down to the receiver. One is represented as high value of frequency and 0 represented as lower value of frequency. Carrier signal is represent how lower value of frequency looks like. The blue form is represent the actual signal. This is high value of frequency. This is lower value of frequency. There are two types of implementation of BFSK. The first one is non-coherent BFSK. They may be discontinued in the phase when one signal element ends and the next begins. Non-coherent BFSK can be implemented by treating BFSK as two ASK modulation and using two carrier frequencies. Non-coherent digital modulation techniques are those techniques in which the detection process does not need receiver carrier to be phase locked by transmitted carrier. The second is coherent BFSK. Coherent BFSK is the phase continues through the boundary of two signal elements. Coherent BFSK can be implemented by using one voltage control oscillator VEO that changes its frequency according to the input voltage. In coherent detection, the local carrier generated at the receiver in phase lock with the carrier at the transmitter. The detection is done by correlating received noisy signal and locally generated carrier. Coherent detection is a synchronization detection. Disadvantages of binary frequency shift keying. The generation of BFSK signal is easier, but it has many disadvantages compared to BPSK signal. Firstly, its bandwidth is greater in comparison to BPSK, and it almost double the bandwidth of BPSK. Secondly, is the error rate of BFSK is higher. Frequency shift keying also have multi-level FSK. Multi-level FSK is not uncommon with the FSK method. It can use more than two frequencies. The frequencies need to be 2 delta apart. For example, we can use 4 different frequencies to send 2 bits at a time. And to send 3 bits at a time, we can use 8 frequencies and so on.
Hi, I'm NurKhalis and I'll be discussing about phase shift keying, or simply called PSK. What does it mean by PSK? In PSK, the phase of the carrier is varied to represent two or more different signal elements. The digital modulation schemes that convey data by changing the phase of the carrier, but both peak amplitude and frequency remain constant. PSK is mainly used in wireless LANs, radio frequency identification, and Bluetooth. Next, I'll be talking about one of the type of PSK, which is binary phase shift keying. Binary phase shift keying is the simplest PSK. It consists of two signal elements, a phase of 0 degree and a phase of 180 degree. Its advantage is it is less susceptible to noise than ASK. The criterion for bit detection is the phase. The noise can change the amplitude easier than phase. PSK is superior to FSK because it does not need two carrier signals. The bandwidth of BPSK is the same as BSK but less than BPSK. The implementation of BPSK, the signal element with phase 118 can be seen as the complement of the signal element with phase 0 degree. BPSK is implemented with polar non-return zero signal, which polar energized signal being multiplied by the carrier frequency. 1 bit or positive voltage represented by a phase starting at 0 degree, the 8 bit negative voltage represented by a phase starting at 180 degrees. Next, it's the quadrature phase shift keying. The QPSK uses two separate BPSK modulation, which is in phase and the other quadrature out of phase. It sends 2 bits of digital information at a time without the use of another carrier frequency. The amount of radio frequency spectrum required to transmit QPSK is reliably half that required for BPSK signal, which in turn makes room for more users on the channel. The implementation of QPSK. Incoming bits are passed through a serial to parallel conversion, which send 1 bit to one modulator and the next bit to other modulator. If duration of each bit in the incoming signal is T, duration of each bit sent to the corresponding BPSK signal is 2t. The peak to each BPSK signal has 1/2 the frequency of the original signal. The two composite signals created by each multiplier are sine wave with the same frequency but different phase. When they are added, the result is another sine wave with one of four possible phases, which are 45 degrees, minus 45 degrees, 135 degrees, and minus 135 degrees. The next topic will be the constellation diagram. Constellation diagram is a diagram which helps to define the amplitude and phase of a signal element when using two carriers, the one in phase and one quadrature. Constellation diagram is useful when dealing with multi-level ASK, PSK, or QAM. A signal element type represented by a dot. The bit or combination of bits can carry written next to it. Has two axes, which is the horizontal x-axis, in-phase carrier, and vertical y-axis, the quadrature carrier. Projection of point on x-axis, the peak amplitude of the in-phase component. Projection of point on y-axis, the peak amplitude of quadrature component. The line that connects the point to the origin is the peak amplitude of signal elements, which is the combination of x and y components. The angle line linked with the x-axis is the phase of the signal element. So, that concludes my presentation today. Thank you very much.
Hi, my name is Najwa and I will be explaining about QAM. What is QAM modulation? QAM is a combination of BSK and LSK, and QAM also is a form of modulation which is widely used for modulating data signals onto a carrier used for radio communications, and it's also got two-dimensional wave, which you can see here. There is sin and cos, and also widely used because it offers advantages over other forms of data modulation, such as PSK, and is also able to carry higher data rates than ordinary amplitude modulated schemes. And there is 4 constellation diagram for some of QAMs, and this one is for QAM, which is simplest scheme, and it got 4 different signal element types using a unipolar NRZ signal to modulate each carrier, and this one is for QAM also, but is still using the NRZ and exactly the same as PSK. And this one is use a signal with 2 positive levels to modulate each of the 2 carriers. And finally, 16 km is a constellation of a signal with 8 levels, 4 positive and 4 negative.